In a rare turn of events, the three-letter agencies are actually recommending that Americans start using encrypted chat apps because state-backed threat actors have managed to hack the major broadband networks in the United States, which is allowing the hackers to spy on people's phone messages. So obviously, the feds are really pissed because they're usually the only ones that get to listen to your calls and read your text messages. And if you're wondering who hijacked the Telecom/spyware networks, it's of course the United States' greatest rivals.
China.
That's right, these hackers have links to China's Ministry of State Security, which is kind of like America's CIA combined with the FBI, and of course, Chinese. And this affiliated hacking group has been launching a number of cyber attacks against US infrastructure and the infrastructure of other countries, going as far back as at least 2020. This is an advanced persistent threat that's gone by a lot of names like Ghost Emperor, Famous Sparrow, King of World, UNC 2286, and most recently, Salt Typhoon. Their primary goal appears to be intelligence gathering, which is pretty common amongst Chinese state-backed threat actors. They'll hack into the networks of militaries or private sector companies to steal research secrets in order for China to improve their tech without having to spend the millions of dollars that other people did on that research and development. But obviously, if these hackers have persistent access to telecom and broadband networks, that could be used offensively as well. Like if China decided to invade Taiwan, communications could be interrupted as that's happening, delaying the military response. We've already seen the complete blend of traditional and cyber warfare in the Gaza and Ukraine conflicts, except China spends more on their hacking program than all of the countries involved in those conflicts combined. So needless to say, these attacks are pretty sophisticated, and the hackers are very diligent about making sure that the malware they use isn't detected by antivirus programs or even forensic analysis that's done on systems once they're known to be compromised. That's part of the reason why it's been so difficult to evict these hackers from US telecom networks. CISA and other security groups know that they're in there, they just don't know exactly where. And it's currently unknown if the hackers have just compromised the edge systems of specific telecom companies and their wiretap systems in order to read people's messages, or the core routers that every phone company and ISP uses to route traffic all over the world. While technical details about this most recent attack have yet to be published, there is a malware analysis report from the National Cybersecurity Center about SparrowDoor, which was a variant of this hacking group's malware that was discovered on a UK network back in 2021. As the name implies, SparrowDoor is a persistent backdoor and loader that targets Windows systems. It communicates with a command and control server over HTTPS, and it supports various automated commands as well as spawning a reverse shell that gives hackers real-time remote access to the infected systems. Some of the persistence techniques used by this malware include creating either a Windows service of itself or a registry key in current version/run, which matches the name of a legitimate Windows service in order to not raise any eyeballs when someone spots this process name using up a lot of their system resources. You might just think that that's Windows being bloated again. The malware starts off by renaming a legitimate and signed Notepad++ updater to searchindexer.exe, which is the name of a legitimate Windows file. The now renamed Notepad++ updater tries to load the libcurl.dll library, which is normal behavior for a process that pulls updates from the internet, but the malware takes advantage of this by giving the loader the same name as the legit libcurl library. So this gets sideloaded by the updater process, which remember has been renamed to searchindexer.exe. The winmain function inside of this process gets patched in memory to make a long jump to a function that's stored inside of libcurl.dll. So when winmain executes, it jumps into the loader function in that DLL, and from there it deobfuscates and executes the actual backdoor, which is contained in libhost.dll. And all of this is done in order to make it appear to security tools that the malware is actually being loaded by the signed updater process that has the same name as a legit Windows file. The malicious libcurl.dll is also designed to not patch the long jump into its parent executable if it gets loaded by run dll32.exe. And this is likely to prevent the malware from executing if it's being run inside of a sandbox. It also does the classic checks against a list of known antivirus process names and limits its activity if any of those are detected. During initialization, the malware injects itself into the svchost.exe process to disguise itself as a legit Windows service, and another interesting evasion technique that this malware uses is it steals the user account token that's associated with the current user's explorer.exe process. And it uses that account token whenever the malware makes communications over the network. Now, this is technically a privilege downgrade since the malware already has system-level access after binding itself to svchost.exe. But this actually helps the malware to blend in because most network activity is made by user processes instead of system ones. So if system was communicating over the network in an abnormal way, that might set off some alarm bells. Now, when the malware is connecting back to its command and control servers, it's doing so over an HTTPS connection, and it's using static XOR keys to encode the data that's being sent and received over that connection. And the malware also uses Windows APIs to close its sockets gracefully as soon as it's done sending and receiving data to ensure that those sockets are only used for the minimum necessary time, again, making it much harder to detect this malware on any given system. Now, since this is an old version of the malware, it's unlikely that the hackers are going to be using the same code base right now because antivirus programs surely have signatures for these files that I described. But there's a million different ways that multi-stage malware loading and evasion techniques can be done, and hell, even rewriting the same exact code in a language like Go or Rust with its more complicated memory model totally changes the signatures of the malware and makes it much more difficult to analyze. So it'll probably be a while before anyone can be certain that hackers have been removed from US networks. In the meantime, you can protect yourself by using an end-to-end encrypted messaging app like Signal. Standard SMS messages are only encrypted over the air, meaning your mobile carrier, as well as Chinese hackers and the police, have those decryption keys and can read your messages whenever they want. The keys for Signal messages, however, stay locally on your device. Messages are encrypted before they are sent and can only be decrypted by the recipient on their device. I would also recommend that you stop using text messages or phone calls for two-factor authentication and switch to using an authenticator app, because depending on what parts of the telecom networks have been compromised, the Chinese hackers could potentially pull off a barrage of SIM swapping attacks where they steal people's phone numbers en masse in order to get those two-factor or account reset codes and compromise every online account that is associated with people's phone numbers. If you enjoyed this video, please like and share it to hack the algorithm, and buy some of my merch from my website based.win. 10% discount store-wide, available at checkout when paying in Monero XMR. Have a great rest of your day.